I'm Swarat. Today we are discussing about motion in a plane with the constant accelerations. Okay, in the last lecture we were discussing about the accelerations. In lecture we will discussing about the motion in a plane with the constant accelerations. Now see here, suppose that an object is moving in an xy plane and its acceleration a is constant over an interval of time. The average acceleration will equals this constant value. Now let the velocity of object be v0 at time t is equals to 0 and v at time t. Then by definitions we will get that the 8 is equals to v minus v0 divided by the t minus 0. So see here, v minus v0 divided by t it is equals to, we will get that the value of that v is equals to v0 minus v0 plus 80. So in terms of component of vx, it is equals to v0x plus axt, and also in the term of y we will write down that the vy it is equals to v0y plus ayt. Now let us now find how the positions of our relay change with the time. We follow the method used in the one dimensional case. Let r0 and the r be the position vector of the particle and time t0 and t, and let the velocity at this instance be v0 and v. Then over this time interval t, the average velocity is that v0 plus v divided by the 2. So see here, the displacement is average velocity multiplied by the 2 by the time intervals are there. So see here, v it is v r minus r0 is equals to v plus v0 divided by 2, it is into t. So it is equals to, also known as the, but v it is equals to v0 plus 80, v it is equals to v0 plus 80 plus v0s are there divided by the 2. We will get the value of that v0 plus 1 half and v0 t plus 1 half 80 square. So now r it is equals to r0 plus v0 t plus 1 half 80 square. It can be easily verified that the derivative of equations of 4.34 in a dr upon dt gives the equations, and it also satisfies the conditions that r it is equal at r it is equals to r0 and t it is equals to 0. So equation can be written in the component form as x is equals to x0 vax into t plus 1 half ax into t square, but and y it is equals to y0 plus, it is in the in the straight line motion in a straight line. On that time what we have a x it is equals to x0 v0 t will have v0 x into 1 half t into 1 half ax t square, and also it is represent in the y directions. Also it represent y0 plus v0 yt into 1 half a t square. So one intermediate interpretations is that the motion in a x and y direction can be treated independently of each other. So that is the motion in a plane. So see here, the motion in a plane can be treated as two separate simultaneous one-dimensional motion with the constant acceleration along to perpendicular to the directions. So this is an important result and is useful in analogy motion of object in two dimensions. A similar result hold for a three dimensions. The notice of perpendicular to directions convenient in a mere physical situation we solve discussed in the projectile motions. Now see here, a particle start from origin at t is equals to 0 and with the velocity is 5.0 meter per seconds and moves in a xy plane. It is a velocity in x direction. See here, I cap it is represented as a x direction. So in xy plane under the action of force which produce a constant acceleration of 3.0 plus 2.0 j cap. It is I cap plus j cap. It means there are the a in the two dimensions are there. So what is the y coordinate of particle at the instant in x direct the coordinate is 84 meters. What is the speed of the particle at this time? So see here, we have r it is equals to v0 t plus 1 half it square. Now v0 starting velocity is that 5.0 I plus 1 half 3.0 I cap plus 2.0 j cap. So see here, the 1 by 2 it will be gives us the divided by the 2. So 1.5 I cap plus 1 j cap into t square. So here 5.0 in I into t plus what will happen 1.5 into t square into I cap plus 1.0 into t square into j cap. So therefore the x represented the is our x-axis and this is our y-axis. So x-axis represent the 5.0 t plus 1 half 1.505 t square and y represent the 1.0 t squares. So see here, this is the what is the speed of particle at this time. So see, now we need to determine the speed. So x versus x, it is equals to t, x into t is equals to 84. So what we will take, x it is equals to 84. So 5.0 into t plus 1.5 into t square, it is equals to 84. So what we will get, we will get that due to the polynomial equations, due to the x square, 2x square minus 5x plus y, ax plus b, ax square plus bx minus plus c. From these equations we will get that the factors of these equations, and then after we will get that the final answers. So t is equals to 6 seconds, so t is equals to 6 seconds, then y it is equals to 1.0 into 6, so it is equals to 36.0 meters are there. So see here, now the velocity v it is equals to dr upon dt. So v, but dr, what the value of that, r it is equals to 5.0 plus 3.0 into t in t into I plus 2.0 into t into j cap. So see here, what we will get, v is equals to dr upon dt. So we will get that the value of t dr upon dt, there are the two t square. So there are the, that's why it is a 1.5 become a 3.0 1.5, and also this is also t square. So on that time it will be get. Now again, what we will get, the value, put the value of 6 seconds. So 5 into 6 3 is 18 23, and in x side, and at 6 to the 12 in the z directions. So what we need to determine the speed. So under root vx square plus vy square, it is, see our, it is vx and it is our vy. So what we will get, vx square plus vy square, it is equals to under root of this phenomena, we will get that the final answer is 26 meter per second square, second meter per second. Now see here, relative velocity in two dimensions. The concept of the relative velocity introduced in the sections, previous sections. Now for motions along a straight line can be easily extended to include motion in a plane or in a three dimensions. Suppose that two objects A and B moving with the velocity V and VB, each with respect to same common frame of reference. Okay, then the velocity of object relative to that of V is VAB, it is equals to VA minus VB. And similarly, the velocity of object B relative to that of A is VBA, it is equals to VB minus VA. So therefore VAB it is equals to minus VA also, and the VAB magnitude of VAB it is equals to VBA. So relative velocity, what is explained in this phenomena? Relative velocity is that whenever we are sitting in the train and someone shows you due to the, and you are showing the outsides of the surface, there are the someone who are, some persons are position it at there. So you will feel like that the main will be motions in there. So but not main is not a motion in motion, but you are in motions. So you will feel that the man is, and out other sides of these things due to the train is moving in the motion. So that's why we are taking that the relative velocity with respect to any reference point. Okay, the ground is our reference point. So this is the basic things are there. So see here, what will happen. So this is our basic things are the relative in the in two dimensions are there. It will be gives us the relative velocity of that VAB, by it is equals to VA minus VB, and VBA it is equals to VB minus VA. So therefore the VAB it is equals to minus VBA. So we will get that the VAB it is equals to VBA. Okay. So thank you guys. If you can't understand in this lecture, then comment in the comment box. Thank you guys. Thank you so much.